back here at John Wilson Elementary School for another issue of Science Fun. I'm Jennifer.
And I'm Bonnie. We will be studying heat transfer. And here's Mr. Walters. Have fun.
Welcome to class this morning. I'd like to start with a little review from what we studied last day, and I'd like you to all come up, sit in a circle around my chair up here. Just have a seat nice and close. There you go. Okay, who remembers what we studied last day? Anybody? On heat? Yeah, Cindy? Yeah? Okay, temperatures, right. Yeah, heat and temperature is what we studied last time. We studied how heat causes matter to expand. You take a railroad rail like this, when it gets hot, it also expands. And that can cause an engineering problem when rails start to expand. Because even though they each only expand maybe a few millimeters, when you put all those rails together and they all expand together, you get a great deal of difference in the length of the railroad track. As a matter of fact, 640 kilometers of railroad track on a hot day expands, guess how far? Any guesses? 300 meters. Exactly. Well, what they do is they leave a tiny space between each rail to allow for expansion and contraction. And next time you walk down a railroad, you should look for that. Because between each rail, there should be a little bit of space for the rail to move back and forth. And if you've ever heard a train go by, they make that clicking sound. Click, 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 click. That's because they're hitting those little spaces. Click, 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 click. And the wheel is so large it doesn't fall into the space. Well, okay, today we're going to go on and we're going to learn two new things. Now, I want you to listen carefully to these two words because we're studying heat transfer. Everybody say that with me.
Heat transfer.
Okay, what that means is how heat moves through matter from one place to another. And there are two ways in which heat moves through matter. So I want you to remember these two words. The first one is conduction. Everybody say that.
Conduction.
Okay, that word might not mean a whole lot now, but it will by the end of the day. And the other way that heat travels through matter is by convection. Again?
Convection.
Okay, that one's not as common as the word conduction, so let's try those again. Conduction?
Conduction.
And convection.
Convection.
Okay, what I want you to do is to return to your seats, and we're going to write those things in our notebooks, and then we'll show some experiments to help you understand those two words. Metals are the best kind of heat conductors. We'll talk about conduction first. Go ahead and write those down as I'm speaking to you. The metals work well. Silver, copper, steel, gold, those are all good conductors of heat. And you've probably felt that in your own experience in physics. If you've cooked a hot dog over an open fire, you know that if you leave that, and if you're using, say, a bent curtain rod, curtain hanger, or a clothes hanger, that's what I'm trying to say, clothes hanger. If you use a clothes hanger to cook a hot dog and you keep it over the fire for a long time, the heat will travel up that hanger and it'll finally burn your hand. So you have to be careful you can't keep that wire in the fire too long. Question? Oh, okay, go ahead and get one. Now I'm going to pretend like some of you are a piece of steel. Could I have everybody in row 1 and row 3 just stand up and make a line right here? It's right behind my desk, Shannon, on that shelf. Yeah, shoulder to shoulder, facing the north side of the room. Okay, everybody shoulder to shoulder. Okay, you people represent this steel rod, all right? You are now a steel rod, and each one of you is a molecule in this steel rod. All right? Let's see, we might use a few more. Patrick, Kelly, and Shannon, row 2, you might as well join on the end of this steel rod here. Okay, now heat can travel down this steel rod by a process called conduction, and this is how it works. I have some flashcards here, and these are going to represent heat. Okay, this is heat energy, and heat energy is going to be conducted down the steel rod. You're the first molecule, Wesley. Here's some heat. Now what you do, yeah, you pass the heat on, and I keep giving you more heat. And you just keep passing it on down the rod. That's heat energy. You getting warm down there yet? Yes. Oh, okay. Now stop. Okay, that took a little while for the heat energy to travel down the rod. And that's what happens in a steel rod. Heat energy travels down. Now that was an example of one kind of heat transfer. What kind was that? Everybody.
Conduction.
A little louder.
Conduction.
Yeah, that's heat conduction. Now once we understand that, we can do some experiments with heat conduction. I have here, sitting in some ice water, a cold rod. Believe me, it's cold. It's been in the freezer all night, and we need to transfer some heat into it because it's nice and cold right now. But I want you to only hold on to one end of it. I don't want you to touch this end with the threads on it. Only this end right here. Now some heat is transferring out of my hand into this rod, and that heat should travel up the rod and warm up the other end. Could you pass that on? Just pass it around the room, always holding on to that end. Now heat's going to come out of every person's hand until, does it feel cold, Jennifer? Yeah. Okay, just keep passing it. Every time that gets passed, more heat gets transferred into that rod. And it'll slowly pass down the rod until the other end gets warm. Over this way. Okay, keep passing the rod. I want you to come up closer and sit on the floor again. And I want to show you another example of heat conduction. Don't touch them. Just watch. Just bring it up with you, Tammy. Have a seat on the floor. How's it doing? How far did it warm up? Up to there? So it's warm all the way up to there. Oh yeah, it feels nice and warm. How about the end? No, it's still cold up there, so we need to keep passing that around until the heat conducts all the way up to the end. Okay, what we have here are some nails that have been waxed onto this rod. Just a little melted candle wax. I can see one of them fell off already. But now what we're going to do is put this flame right under the end of this rod. Now, what should that heat do? Tell me what you know already about heat conduction. What do you expect might happen? Go ahead, Shannon.
The heat's gonna go all the way through the bottom, and the wax is gonna melt, and then the nails are gonna come off.
Well, which one do you think will come off first?
The first one.
Why? The last one? The first one? Well, I hear some controversy here. Well, which do you call first and which do you call last? Let's call this number 1. 2, 3, 4, 5, 6, 7, 8.
8.
You think 8 will fall off first? How many of you think 8 will fall off first? How many of you think number 1 will fall off first? Well, okay, let's watch and see. You've made a scientific prediction. We have it heating up there. Maybe I should move that flame just a little closer to number 1 so that we can get this heat to conduct its way along there a little faster. Kind of like passing the cards. The whole rod is warm now? Oh yeah, the heat just warmed it up all the way. Neat. That's a neat one. It warmed up the whole thing. Hey, hey, what happened? One fell off of there. Well, maybe that was just a fluke. Well, okay, you just keep watching that. I'm going to show you another thing that's interesting with heat conduction while we're waiting for the next one to fall. Here's a piece of ordinary string, right? Now I'm going to take this ordinary string, and I'm going to wrap it around this pencil. By the way, a pencil is a poor conductor of heat. I told you that metals are good, right? Wood is a poor conductor of heat. So is plastic. And some kinds of asbestos and glass is even a poor conductor. And it's a good thing we have some poor conductors, and if you look at this frying pan here, you can see that this metal is a good conductor of heat, but this handle is a poor conductor. It doesn't transfer or conduct heat very well. So that's why they make handles out of this, so that you won't burn your hand. Otherwise the heat would conduct itself all the way up the handle and burn you. Hey, number 2.